All right, guys, I'm going to quickly go over problems 15 and 16 on the test. You run, jump, and slide across some snow. You're pretty sure that you are running at 5 meters per second, but then you slid 8 meters per second before you stop. What is your coefficient of friction? So it says that you're originally running at 5 meters per second. We know you're going to stop, so final is 0. And we know you're going to travel 8 meters. 3 kinematic variables means we can do kinematics straight away to get acceleration. So you're going to use VF squared equals VI squared plus 2a delta x. That's 0. Subtract VI squared over, then divide by 2 and delta x to get a. Plugging in, that's negative 5 meters per second squared over 2 times 8 meters, and this ends up as negative 1.5 meters per second squared. Calculating that was worth 2 points on the problem. Okay, then, or earlier, you could do a force diagram. We are sliding, so we have force of gravity, we have force normal up, and we have force friction back of, I didn't draw a picture. I'm messing up here, so let's go, there you are, sliding face first across the surface of the ground. There's your force diagram. So we can then sum the forces in the y equals mass times acceleration in the y, and it's not accelerating in the y, so there you go. Force normal is up, force gravity is down is equal to 0, and so we get force normal is equal to force gravity. This is where a lot of people got stuck because they didn't have mass, but the usual way of solving this is to proceed as though you do have mass. Proceed as though it's going well. And so force of gravity is equal to mg. Then we're going to go find, so we technically have force normal. So we're going to sum the forces in the x to get force friction. The only force in the x is negative force friction, and it is accelerating. So there's my equation. As a matter of fact, I could do this. I could say force friction is equal to negative ma. Then the coefficient of friction is equal to force friction over force normal. And force friction we just found a second ago is negative ma. And force normal, we calculated a minute ago, is mg. And so you see that m over m will in fact cancel. So mu is equal to negative times the acceleration. So it's a good thing that was negative, so they cancel. All over g, which is a positive 9.8. So mu is equal to 0.16. Going to problem 16. We have a person going down a hill on skis. We know that their mass is 50 kilograms. We know that the coefficient of friction is 0.12. We know that they're initially traveling at 6 meters per second, which we find later is actually irrelevant. We also know that the angle of the hill is 13 degrees. And I believe that's all the numbers given to us, and the goal is to find acceleration. So we've got a person on skis here. Force diagram is going to be gravity down. I'll move this a little bit. Force normal is up at an angle, and friction is going to be back. Since acceleration is not on an axis, we should probably shift the axis. So I'm going to draw my dotted line straight through here and down parallel. You can see that I was just turning that about 13 degrees clockwise in this fashion. So that means this got moved left right here, 13 degrees. Now I'm going to sum the forces in the y. The new y does not have any acceleration, or you could also say the perpendicular doesn't have any acceleration. So we have force normal minus force gravity in the y is equal to 0. So force normal is equal to force gravity in the y, which if I look over here at my trig, I'll redraw this. Force gravity is mg. This is that 13 degrees we said just a second ago, and here's force gravity in the y. So since I can see it's adjacent, this is going to be mg cosine of the angle. Most of you decided to plug numbers in at this point, so I'll go ahead and do that, even though you technically don't have to. This is 50 kilograms times g times cosine of 13 degrees, and I believe that is about 477 newtons. With that, you can go get friction using the model of surface friction. So I'm going to multiply 0.12 times that 477 newtons. And I'm going to end up with 57.3 newtons. Then I'm going to sum the forces in the x. Our whole goal here, once again, is acceleration. It is accelerating in the x, so I'm not going to touch that. According to here, I do have a positive force gravity in the x minus force friction equals mass times acceleration in the x. And I'll erase that x because that's all accelerating in the x. A little bit of algebra. All I got to do is divide the mass underneath to get acceleration. To get force gravity in the x, that's going to be mg times the sine of the angle, because you can see over here, there it is, force gravity in the x is the opposite of that particular side. So minus force friction over m equals a. And let's go ahead and plug our numbers in now. That is 50 kilograms times g times the sine of 13 degrees minus 57.3 newtons that we just calculated a minute ago, divided by 50 kilograms is equal to acceleration. And if you plug that all in, you should end up with 1.06 meters per second squared. So it looks like they're speeding up going down the hill. And that's how to do 15 and 16.